Hey everyone, and welcome to today's Explainer. We hear constantly about the absolute magic of artificial intelligence, but behind that sleek, digital curtain is a reality we very rarely talk about. We're talking about a massive, heavy, and honestly incredibly resource-hungry physical footprint. Today we're going to dive deep into the hidden environmental costs of this amazing technology, and we're driving this entirely by the latest scientific understanding, industry reports, and energy research.
So let's start with a basic question. Where does artificial intelligence actually live? It's so easy to just assume AI is this weightless, invisible force floating somewhere out there in the digital ether, right? When we type a prompt or ask our phone a question, the answer just magically appears. But AI doesn't live in a vacuum. It requires a massive, highly complex physical home to exist at all.
And honestly, we have this massive disconnect with modern technology. We always picture an immaterial cloud, something completely detached from the physical world. But the reality? Every single AI query you type, every crazy image you generate, and every model that gets trained relies on a vast, incredibly heavy global infrastructure. We're talking about giant data centers, complex semiconductor manufacturing, and immense energy systems. The digital revolution, it turns out, is incredibly physical. So let's peel back that first layer. Section 1, the physical reality of AI, or basically the hardware that makes it all tick. Think about what actually makes up the brain of AI. We're talking about thousands, sometimes literally millions, of servers packed into high-performance computing clusters, all housed inside these massive warehouse-sized data centers. You've got specialized hardware like GPUs and TPUs built specifically for intense AI computation. And because these machines run so incredibly hot, you need robust cooling systems just to prevent them from literally melting down. Plus, all the networking and storage just to connect the whole shebang. Major operators like Google, Microsoft, Amazon, and Meta are rapidly expanding this infrastructure globally, and it's running 24 hours a day, 7 days a week. It is a critical, always-on global foundation.
All that continuous, round-the-clock operation leads us directly to Section 2, surging energy and carbon costs.
Hundreds. Keep that number in your head, because it's absolutely crucial. Modern AI models require massive parallel computation and repeated training cycles that involve literally trillions of operations. Depending on the scale and architecture, training just one single large AI model can require the exact same amount of energy as powering hundreds of homes for extended periods. When you apply that tangible comparison to the quick prompt you just typed into your phone, it really helps you grasp the staggering amount of electrical power required before an AI is even rolled out for public use. And look, this isn't just speculation, it is hard scientific reality. The International Energy Agency reports that data center electricity demand is rising rapidly, fueled in a huge way by massive AI adoption. In fact, data centers are becoming one of the fastest growing sources of electricity demand worldwide. And it's not just the initial training of the models either. It's the continuous AI inference, meaning every single user request, combined with cloud storage and streaming growth, that is pushing this demand absolutely through the roof.
But the environmental impact isn't just about plugging these things into the power grid, it's a cumulative life cycle footprint. First, step 1, manufacturing GPUs and servers is a highly energy-intensive process. Then, step 2, that hardware has to be transported all over the globe. Step 3, once it's finally installed, it requires continuous cooling just to function. And step 4, because technology moves so incredibly fast, this outdated equipment is frequently replaced every few years. So even if a tech company buys renewable energy credits, the local physical grid mix still matters, and the cumulative carbon footprint starts long before the computer is even turned on. Which actually brings us to a critical and honestly mostly ignored layer of all this. Section 3, hidden water and resource drains. Okay, so because data centers generate such intense heat, they need really sophisticated water-based cooling systems like evaporative cooling. It's kind of ironic that the weightless cloud often needs its own personal river just to cool down. But the reality is quite serious. Imagine living in a drought-prone area, and a massive data center down the road is drinking millions of gallons of water just to keep its servers from overheating as AI workloads spike. It competes directly with local agricultural and residential needs, which can create a major sustainability crisis. And the resource drain goes deep into the earth, too. It starts with extracting rare earth elements, lithium, and cobalt. Then comes fabrication, which requires highly specialized plants with intense water and chemical usage. Next is usage. And here's a wild fact. Because AI moves at such breakneck speed, state-of-the-art chips become entirely obsolete in just a few short years. That fuels the final stage, e-waste. It's one of the fastest growing waste streams globally, and since complex chip materials are incredibly hard to recycle, we are seeing the permanent loss of recoverable rare metals.
Now, right about now, you might be wondering, wait a second, aren't computers getting more efficient? That brings us to section 4, the AI efficiency paradox. This introduces a truly fascinating, kinda counterintuitive concept from environmental economics called the rebound effect. It completely challenges our basic assumption that better technology automatically equals less waste. The rebound effect dictates that when efficiency improves, total consumption often actually increases. Let's look at exactly how this plays out in the world of artificial intelligence. Here's how the paradox works in action. Step 1. AI models become more efficient, which lowers the cost per query. Step 2. Because it's cheaper and faster, the barrier to entry drops and usage completely explodes. People and companies start using AI for absolutely everything. Step 3. That massive scale drives the total energy demand right back up. The demand is highly elastic, so making AI greener per query can actually result in a vastly larger total environmental footprint because we end up using it exponentially more. Okay, take a breath. It's not all doom and gloom here. Let's pivot to section 5, strategies for sustainable AI. The industry is absolutely fighting back with 5 major strategies to try and align AI growth with our planetary limits. First, we're seeing massive investments in renewable energy. Companies are building dedicated solar, wind, and hydro specifically for their data centers. Second, researchers are building hyper-efficient models that need far less computation to maintain performance. Third, we're seeing some wild advanced cooling innovations, like liquid immersion cooling or literally reusing the heat generated by servers to warm nearby homes and buildings. Fourth, there's edge computing, which decentralizes data to process it closer to you. And finally, hardware optimization, designing brand new chip architectures focused purely on energy efficiency rather than just raw speed. But of course, technology alone can't fix the whole shebang, right? We also need proactive governance. Data centers are becoming as critical to our modern infrastructure as transportation or utilities. So governments are stepping up with energy efficiency standards, mandatory carbon reporting, strict water usage monitoring, and incentives for renewable-powered infrastructure. While regulation almost always lags behind rapid software innovation, these policy steps are absolutely essential to manage the very real physical reality of AI. The International Energy Agency has made it crystal clear. Digital infrastructure has to become significantly more energy efficient if we're going to meet global climate goals. AI is, without a doubt, one of the most transformative technologies in human history. The challenge isn't whether it's beneficial, but rather this fundamental question: can we build intelligent systems that are powerful and environmentally responsible? Ultimately, the future of AI relies entirely on how we balance rapid innovation with the physical constraints of our planet. Thank you so much for joining me on this explainer. Keep asking the big questions.